Hello and welcome back to my video tutorials for AP Stats. Today we're going to talk about Chapter 24, Comparing Means. In this chapter we're going to determine whether or not two population means are different based on sample values. So similar to what we did in Chapter 22, but now we're dealing with means. The notation is slightly different. Instead of P1, P sub 1, P sub 2, we're using mu sub 1, mu sub 2. So the null will always be there's no difference. And the alternative will either be there's a difference, one's greater than the other, one's less than the other. And it's always based on the context of the question. Let's take a look at a reading example. So in a reading example, we have smokers and non-smokers, and we're trying to find out if the mean pulse rate, sorry about that, if the mean pulse rate between the smokers and non-smokers is different. That's what it says in the question. And so we use the null, there's no difference, and then here we're using a two-tailed test that they're different. So in these tests, we have conditions. So we've got a different condition for nearly normal. It's the same for means, independent groups. So we have independent groups. We've got smokers and non-smokers. They've been randomly chosen, and N is definitely less than 10% of all possible smokers and non-smokers. And in the question it says that both sets of data were roughly symmetric and had no outliers. So someone had already taken the sample, take a look at the histogram or probability plot, and so we want to check both groups for normality from the samples, so we can infer that indeed they come from a normal population, and we can proceed with our T-model inference test. So here's our little statement. Under these conditions, the sampling distribution of the difference of these means follows a T-model with 56 degrees of freedom, T56. We will use a two-sample t-test at alpha level 0.05. Now, where did I get this? Well, this is the case of putting the cart before the horse. We actually use the calculator to get the degrees of freedom. So we actually have to run the test first, get the degrees of freedom. There is a formula in the book that's very complicated that you can use to find the degrees of freedom. And there's also a shortcut one, which we don't want to use. Excuse me. Okay, where was I? Okay, so we have this this statement. The conditions are met. I will follow a T-model, tell the model that we're using, and name the test. And we run the test first to get the degrees of freedom. And we'll talk more about that in class. So the mechanics, very similar to what you've seen already from Chapter 22. We've got the T-statistic where we've got the difference of the means. Here, oh, I forgot to write something here. I forgot the squared. We're going to square that and square that. So we're adding variances again. And we're going to take the sample standard deviation squared divided by the sample size plus sample standard deviation squared divided by the sample size of the second sample and add them together. So that's adding the variances and then taking the square root. So usually you'll get a set of data or you'll be given all the statistics for the data. And I like listing them so I know who's where and so forth. So here's what it looks like. And we get a T-statistic of 4.154. And then since it's a two-tailed test, not only do we want the area on this end, we want the area over here as well. So we're going to add those two areas together. Actually, it looks more like that. There we go. And so when we do that, we end up with a p-value of 0.00012. So it's T-CDF, T-critical, going up to 99, and then degrees of freedom, and we're going to just times it by 2. So the conclusions are the same as what we've seen before. It's a decision on the null based on the p-value. So with such a small p-value, we reject the null. There's evidence to show that the mean pulse rates between smokers and non-smokers is different. Now, how different? You guessed it, confidence interval time. We always want to use a confidence interval to show how different things are when we reject the null. Now the confidence interval, pretty much the same setup as we've seen before. It's the difference. We need t-critical, and we have the standard error of the difference of the means. So in this case, t-critical for 56 is 2, roughly 2. And then here's our standard error of the difference of the means. And we end up with the interval 3.11, 8.89. And it's the same interpretation. We are 95% confident that the average pulse rate for smokers is 3.11 to 8.89 beats per minute higher than for non-smokers. So that's how big of a difference. Now, if 0 was in the interval, then it would have made no difference. But since this entire interval is higher than 0, then smokers have a higher pulse rate based on the sample. I hope you found this helpful. Please bring in your questions tomorrow when we hit chapter 24, running. Bye-bye.